Earth's journey began approximately 4.6 billion years ago. Throughout this long journey, our planet underwent countless changes. Massive asteroid impacts, global catastrophes, mass extinctions, and dramatic transformations took place. Yet amid all these events, there were also long periods of calm and stability that lasted for millions of years. Earth has remained a planet of constant change and evolution since its formation. This blue world, suspended in the depths of space. As far as we know, it is the only planet that harbors life. But how did this planet come into existence? How did the first oceans form? When were the foundations of life first established? In this video, we will explore the extraordinary story of Earth from its birth to the present day. Throughout our journey, we will explore the four major geological eras that shaped Earth's history. Hadean Eon, 4.6 to 4.0 billion years ago. The Archean Eon, 4.0 to 2.5 billion years ago. The Proterozoic Eon, 2.5 billion 541 million years ago. The Phanerozoic Eon, 541 million years ago present. Each of these played a crucial role in shaping our planet into the world we know today. If you're ready, let's travel back billions of years and begin our journey to the earliest days of Earth. Enjoy the journey. The first chapter of Earth's history is the Hadean Eon, a period that lasted approximately 500 million years. This period represents the earliest chapter of geological time, witnessing the formation of our planet and its first major structural transformations. Around 4.54 billion years ago, the foundations of the solar system began to take shape. Everything began when a massive cloud of gas and dust collapsed under its own gravity. As a result of this collapse, the Sun formed at the center, while a vast rotating disk of material developed around it. Countless particles of dust and rock within this disk gradually collided and merged over time. Over millions of years, this process led to the formation of increasingly larger celestial bodies. These primitive structures, known to scientists as planetesimals. Under the influence of gravity, they continued to grow and eventually developed into young planetary cores. Objects located farther from the Sun experienced a very different fate. Because more material was available in their surroundings, they were able to grow to much larger sizes. These massive cores attracted vast amounts of hydrogen and helium, eventually forming the gas giants of the solar system. Thus, Jupiter, Saturn, Uranus, and Neptune came into existence. Closer to the Sun, however, temperatures were far higher. As a result, only rock and metal could accumulate in these regions. As a result, the terrestrial planets, Mercury, Venus, Earth, and Mars, began to take shape. However, the young solar system was far from a peaceful place. For millions of years, planetary embryos collided with one another, merged together, and were repeatedly reshaped. By the end of this chaotic process, only four major terrestrial planets remained in the inner solar system: Mercury, Venus, Earth, and Mars. After this formation process, which lasted approximately 100 million years, the solar system began to take on the overall structure we recognize today. Shortly after Earth's formation, the solar system was still a highly chaotic place. During this period, a young celestial body known as Theia, believed to have been about the size of Mars, began approaching Earth's orbit. Due to the gravitational influence of other planets, its trajectory gradually changed, and it eventually collided with the young Earth. This was one of the most significant events in our planet's history. The immense force of the collision shattered much of Theia. A significant portion of its iron-rich core merged with Earth's interior layers, while a massive amount of rock and debris from both bodies was ejected into space. This cloud of superheated material, orbiting around Earth, gradually came together to form a single celestial body. And that is how the Moon was formed. At that time, the Moon was much closer to Earth than it is today and exerted powerful effects on the planet. The Moon's gravitational pull not only slowed Earth's rotation but also helped stabilize the planet's axial tilt. It also gave rise to the first powerful tidal movements on Earth. On the young Earth, a single day lasted only a few hours, while a year contained far more days than it does today. For millions of years following the Moon's formation, Earth remained an extremely active and intensely hot planet. Constant meteorite impacts released enormous amounts of energy. In addition, the decay of radioactive elements within the planet generated significant amounts of heat. As a result, much of Earth remained in a molten state. Its surface was covered by a vast ocean of magma, stretching to depths of several kilometers. Over time, the planet's internal structure began to take shape. While heavier elements such as iron and nickel sank toward the center, lighter materials remained in the upper layers. As a result of this process, Earth's core, mantle, and outer layers became separated into distinct regions. As the magma on the surface gradually cooled, the first solid crust began to form. However, this crust was far from stable. In many places, it cracked, fractured, and broke apart into massive sections. It was during this period that the foundations of the tectonic plates, destined to become continents billions of years later, were first established. Around 4.4 billion years ago, Earth began to cool gradually. The surface was covered with volcanoes, mountains, and countless impact craters. Active volcanoes continuously released gases and water vapor into the atmosphere. At that time, temperatures were so high that water could exist only in the form of vapor. However, as the planet continued to cool, a critical threshold was finally crossed. The water vapor in the atmosphere began to condense, and the first rains in Earth's history began to fall. These rains did not last for days or months. They fell upon the planet's surface as immense downpours that continued for millions of years. The waters descending from the sky filled impact craters, gathered in valleys, and began accumulating in low-lying regions. Over time, the first lakes began to form. These bodies of water eventually merged, giving rise to Earth's first oceans. The foundations of the oceans that now cover most of our planet were laid through this long and extraordinary process. The next major chapter in Earth's history is the Archean Eon. This period, which lasted approximately 1.5 billion years, was extremely important for the emergence and development of life on our planet. Earth had now largely taken shape, but it remained a highly active and dangerous world. Orbital shifts among the giant planets disrupted the stability of countless celestial bodies located throughout different regions of the solar system. As a result, asteroids and comets were sent hurtling toward the inner solar system. For millions of years, Earth was subjected to an intense bombardment of meteorites. Many of the massive impact craters visible today on the surfaces of the Moon, Mars, and Mercury are remnants of this period. Some of these celestial bodies were hundreds of kilometers in diameter, and when they struck planets, they released unimaginable amounts of energy. These impacts did more than just reshape the surface, they vaporized portions of the oceans. They altered the composition of the atmosphere and completely reshaped the appearance of the young Earth. The planet now possessed abundant liquid water, and energy from the sun was driving chemical processes. During this period, the sun was not as bright as it is today. Despite this, the high concentrations of carbon dioxide and methane in the atmosphere created a powerful greenhouse effect, keeping the planet warm. As a result, the oceans did not freeze, and environments suitable for life began to emerge. In these primitive oceans billions of years ago, the first microorganisms began to emerge. For the first time in Earth's history, life was making its appearance. Cyanobacteria living in coastal regions gradually formed vast colonies, laying the foundation for a process that would eventually change the future of the planet. Earth during this era may have resembled Saturn's moon Titan, with its dense atmosphere, hazy skies, and primitive surface. Over time, cyanobacteria developed an extraordinary ability, photosynthesis. These organisms used energy from the sun to process carbon dioxide and produce organic matter. A byproduct of this process was oxygen. At first, the oxygen that was produced could not accumulate in the atmosphere. This was because it reacted with dissolved iron in the oceans, forming iron oxide. For millions of years, the oxygen being produced effectively rusted the planet's oceans. However, over time, the iron reserves in the oceans became largely depleted. After that, oxygen began to accumulate in the atmosphere for the first time. This development became one of the most important turning points in Earth's history, because it paved the way for the emergence of more complex forms of life in the ages to come. Intense volcanic activity on the ocean floor caused enormous quantities of lava to accumulate. Over millions of years, these layers of rock piled up one upon another, reaching thicknesses of tens of kilometers in some regions. Over time, these massive structures began to rise above the surface. At first, small landmasses started to emerge. Later, these landmasses expanded and formed the foundations of the first continents. Earth was no longer a planet covered entirely by oceans. The first lands had begun to appear on the horizon, and our planet was moving toward a new era. Toward the end of the Archean Eon, Earth's atmosphere still contained high concentrations of greenhouse gases. Methane and carbon dioxide, in particular, were among the most important factors keeping the planet warm. However, over time, the chemical composition of the atmosphere began to change. As the concentrations of these gases decreased, the greenhouse effect weakened, and Earth's energy balance began to shift. As a result, one of the first major ice ages in Earth's history took place. During this event, known to scientists as the Pongola glaciation, temperatures dropped significantly and vast regions became covered in ice. This period is considered one of the first major climate changes Earth ever experienced. And now, one of the longest and most important chapters in Earth's history is about to begin. The Proterozoic Eon, which lasted approximately 2 billion years, played a decisive role in shaping our planet into the world we know today. During this era, the atmosphere underwent profound changes, life became increasingly complex, and the foundations of future animal life were established. Earth was no longer just a young planet inhabited solely by microorganisms, it was preparing to enter a new biological era. For billions of years, cyanobacteria living in the oceans continuously produced oxygen through photosynthesis. The oxygen being produced could now accumulate freely. The composition of the atmosphere was changing, and Earth was entering an entirely new era. Scientists refer to this transformation as the Great Oxygenation event. This event fundamentally transformed not only the atmosphere but also the future of life on Earth. Today, oxygen is essential for life. But at that time, the situation was quite the opposite. Most living organisms on Earth had adapted to life in environments without oxygen. As a result, the rapid rise of oxygen in the atmosphere had deadly consequences for many forms of life. Countless microorganisms perished. The planet was experiencing a major biological crisis. However, this crisis also created new opportunities. Because oxygen made it possible to generate far more energy, paving the way for the emergence of larger and more complex forms of life. As oxygen levels in the atmosphere increased, methane levels began to decline. This was significant because methane is a much more powerful greenhouse gas than carbon dioxide. As methane levels declined, Earth's temperature began to decrease. The planet was gradually cooling, and glaciers were expanding. This process eventually led to one of the most extraordinary climate events in Earth's history. Around 2.4 billion years ago, our planet entered a prolonged period of extreme cooling. Temperatures in some regions are thought to have fallen as low as -50°C. Glaciers advanced from the poles toward the equator. Much of the oceans became covered by thick layers of ice. The continents were almost entirely covered by a blanket of ice. From space, Earth looked less like a blue planet and more like a giant frozen snowball. For this reason, scientists refer to this period as Snowball Earth. Although much of the planet's surface was frozen, life did not disappear completely. In the depths of the oceans and in regions beneath the ice sheets, some forms of life managed to survive. These small refuges of life would eventually form the foundation for Earth's recovery in the future. Deep within Earth, the core and mantle were still generating vast amounts of energy. Volcanoes continued to remain active for millions of years. These eruptions continuously released carbon dioxide and various gases into the atmosphere. Under normal conditions, some of these gases would be absorbed by rocks and the oceans. But because the planet was covered in ice, this natural cycle had largely come to a halt. As a result, greenhouse gases began to accumulate in the atmosphere. Over time, temperatures began to rise. The glaciers retreated, and the oceans re-emerged. And once again, Earth became a world capable of supporting life. This cycle of freezing and thawing occurred more than once in our planet's history. Around 2.2 billion years ago, a supercontinent known as Columbia formed on Earth. For hundreds of millions of years, a significant portion of Earth's land was concentrated within this single landmass. But the planet's internal forces never stopped. Over time, movements within the mantle created immense stresses beneath the continent. Deep fractures began to appear. Volcanic activity intensified. New ocean basins began to form. About 600 million years later, Columbia broke apart and disappeared into history. But this was not the end. After drifting apart, the continents began to come together once again. And around 1.1 billion years ago, a new supercontinent emerged, Rodinia. Nearly all of Earth's landmasses were once again united into a single massive landmass. Much of Rodinia was characterized by a harsh and arid climate. Vast barren landscapes, rocky plains, and rust-colored surfaces covered much of the continent. During this period, life was still largely confined to the oceans. Over millions of years, immense stresses built up beneath Rodinia. Eventually, the continent's crust fractured, forming vast rift systems. Magma reached the surface, triggering the formation of new oceans. Around 850 million years ago, Rodinia began to slowly break apart. This event would completely reshape Earth's geography. Around 600 million years ago, the atmosphere was very different. After billions of years of production, oxygen had accumulated to significant levels. Some of this oxygen underwent chemical transformations in the upper atmosphere, forming ozone molecules. As a result, an invisible protective shield formed around Earth, the ozone layer. This development was revolutionary in the history of life. The land was no longer exposed to deadly radiation. Living organisms could now leave the safety of the oceans and begin spreading into new habitats. And Earth entered a new era in which biodiversity would flourish. During this period, the first complex multicellular organisms emerged. Scientists refer to this community of organisms as the Ediacaran biota. However, about 40 million years later, most of them disappeared. We are now approaching the final major chapter in Earth's history, the Phanerozoic Eon. Although it is one of the shortest periods in our planet's history, most of the life we see today took shape during this time. Plants, animals, giant reptiles, mammals, and eventually humans emerged during this period. Around 541 million years ago, an event known as the Cambrian explosion triggered an unprecedented surge in biodiversity. After millions of years of relative simplicity, life diversified dramatically in a relatively short period of time. New groups of organisms emerged. The oceans teemed with diverse forms of life. The origins of many animal groups living today can be traced back to this period. For the first time in evolutionary history, complex ecosystems began to emerge. One of the most important innovations of this period was the emergence of hard body structures. For the first time, organisms began developing shells, exoskeletons, and mineralized protective tissues. These structures made them more resistant to predators. They also increased the likelihood of fossilization. As a result, the fossil record became much richer from the Cambrian period ONW. Around 530 million years ago, continental movements began reshaping Earth's surface. As landmasses collided, vast mountain ranges rose across the planet. Some rocks found today in Scotland, Scandinavia, Greenland, and Canada were once part of the same mountain range. This ancient mountain building process is one of the most remarkable examples of Earth's ever-changing surface. Around 480 million years ago, life began to move beyond the boundaries of the oceans. The first land plants appeared. These organisms resembled modern mosses and primitive terrestrial plants. To survive the harsh conditions on land, they evolved specialized adaptations. These included protective surfaces that helped reduce water loss, and simple root systems that helped them anchor themselves in the soil were among these adaptations. After billions of years of remaining barren, Earth's land surfaces were finally beginning to change. Around 400 million years ago, atmospheric oxygen levels reached a new threshold. This transformation opened a new chapter in the history of life. The first animals began leaving the safety of the oceans and ventured onto land. These pioneering creatures were the distant ancestors of modern-day scorpions, millipedes, and insects. Life was no longer confined to the seas. The continents, too, were beginning to be inhabited by living organisms. Around 390 million years ago, plants developed an extraordinary innovation, the seed. This small biological structure largely eliminated plants' dependence on water for reproduction. Now, new generations could spread to more distant regions and survive in a wider range of environmental conditions. This innovation helped land ecosystems expand rapidly. As forests spread, Earth's landscape began to change. Around 359 million years ago, much of the planet was covered by dense, humid forests. Giant ferns, primitive trees, and vast swampy ecosystems covered much of the continents. Atmospheric oxygen levels were extremely high. This allowed some creatures to grow to gigantic sizes. Some dragonflies soaring through the skies had wingspans exceeding 70 centimeters. Giant millipedes and massive arthropods roamed the forest floor. This era witnessed insect sizes never seen at any other time in Earth's history. The Carboniferous period is also known as the time when most of the coal deposits we use today were formed. Over millions of years, accumulated plant remains transformed into coal, creating the energy resources of the future. Around 335 million years ago, Earth's landmasses began to merge. Eventually, most of the planet formed a single supercontinent, Pangaea. Pangaea was one of the largest landmasses in Earth's history. It was surrounded by a vast global ocean. The coasts were rich with life, but the interior regions were dry and arid. Vast deserts formed, and the climate became harsher. This new world forced many species to adapt to changing conditions. Around 252 million years ago, Earth experienced the largest mass extinction in its history. In this catastrophe, known as the Great Dying, 70% of land species and 95% of marine life vanished. Life nearly collapsed, but this devastation paved the way for new groups of organisms to emerge. Life found a way to recover. At first, they were small and agile, but over millions of years, they became the dominant life forms on Earth. Dinosaurs were far more diverse than we often imagine. Some were fierce predators, while others were giant plant eaters. They ranged from the size of a chicken to some of the largest land animals ever to exist. During this period, seas advanced and retreated, leaving behind thick layers of salt. Over time, these layers contributed to the formation of oil, natural gas, and groundwater reserves. Around 200 million years ago, large asteroids struck Earth, creating massive craters, earthquakes, and tsunamis. Soon after, the planet experienced another mass extinction. While many species disappeared, dinosaurs grew stronger and became the dominant life forms. During this time, Pangaea also began to break apart. The new ocean that formed between the separating continents eventually became the Atlantic Ocean. One of the most remarkable developments in dinosaur evolution was the emergence of feathers. The first feathers did not evolve for flight. They were used for insulation, communication, and attracting mates. Over time, evolution took these structures in a different direction. In some species, feathers began to enable gliding and eventually flight. Millions of years later, a new group would emerge from the descendants, birds. During the Jurassic and Cretaceous periods, dinosaurs ruled Earth for about 180 million years. Some grew to enormous sizes, while others remained small and agile. The planet was warmer, sea levels were higher, and vast forests covered much of the Earth. Around 130 million years ago, the first flowering plants appeared and transformed ecosystems. Meanwhile, India drifted northward, collided with Asia, and began the formation of the Himalayas. Around 66 million years ago, a giant asteroid struck Earth. This catastrophic event triggered global disasters, wiping out most dinosaurs and ending their reign. However, some small feathered dinosaurs survived. Modern birds are the descendants of these surviving dinosaurs. After the extinction of the dinosaurs, mammals rapidly diversified and became the dominant life forms on Earth. Whales, elephants, and primates evolved during this period. Eventually, the path leading to the human lineage emerged. Around 56 million years ago, Earth became much warmer. During this time, extraordinary creatures such as Titanoboa, a giant snake over 13 meters long, roamed the Earth. Over millions of years, continents drifted, mountains rose, and Earth gradually took on its modern appearance. The Great Rift Valley formed in Africa, Antarctica became covered in ice, and Iceland rose through volcanic activity. Around 7 million years ago, the earliest ancestors of the human lineage appeared in Africa. Lucy, who lived 3.2 million years ago, was one of the earliest human ancestors capable of walking on two legs. The Ice Ages, which began around 2.6 million years ago, shaped both life and human evolution. The world in which humanity would emerge was shaped under these harsh conditions. Around 2.4 million years ago, Homo habilis emerged and began using the first stone tools. Later, Homo erectus learned to control fire, marking a major step in human evolution. Neanderthals lived in Europe and Asia, and later, around 300,000 years ago, Homo sapiens emerged. Through language, imagination, and cooperation, modern humans spread across the globe. Around 10,000 years ago, the agricultural revolution began. Humans adopted a settled way of life, and the first civilizations emerged. Around 3500 BCE, the invention of writing marked the end of prehistory and the beginning of recorded history. Billions of years ago, Earth was a young planet of molten rock. Today, it has become a world filled with life and civilization. Humanity became the first species capable of understanding its planet's past and influencing its future. Earth is about 4.54 billion years old and continues to change even today. Continents are still moving, mountains are still rising, and climates continue to change. Over time, humans began to study the sky. Through science, humanity discovered that Earth is only a small part of a vast universe. Over the past few centuries, humanity has made extraordinary progress, from the Industrial Revolution to space travel. For the first time, we looked at Earth from space and saw its place in the universe. Today, humanity is the first species with the power to influence the future of the planet. It can alter the atmosphere, oceans, and ecosystems, and is even preparing to reach other planets. The story of Earth, born billions of years ago, is still unfolding. And much of the next chapter will be written by humanity itself. The next great discovery may be waiting just beyond the horizon. Follow Axiom Earth. Explore the past. Understand the present. Imagine the future.